The average age of aircraft in the Air Force inventory is 27 years. That means we have to make or procure a lot of spare parts to keep all these planes flying.
I think for our airmen, it's really exciting to be able to turn a need and to have some sort of solution turned around and be holding a part much faster than they ever imagined, and oftentimes at lower cost. So the Mammals program, it originated from the fact that there's, in sustainment settings, a lot of parts that we have trouble sourcing, a lot of parts that need replacing in an aging fleet. Suppliers may or may not be there anymore, so we're really trying to deliver some solutions and a knowledge base for those personnel to be able to either make those parts themselves or to be able to source it from a strengthened supply chain to get those parts quickly and affordably, where they're really challenged to do that right now.
The first phase was really to get to know all the operational needs. We were sending people to the logistics centers to try and understand where all the sustainment needs were and what were the highest priorities. So within the phase one, we had a lot of teams, a lot of projects, about 26, 27, 28 different technology projects, and they're still ongoing. From there, the second year of funding came in, and we said we really need to attack the airworthiness statutes, and we need to do it for families of parts. So we started down the efforts for bell cranks, oil coolers, fairings, and expanded these teams. So phase three is in two parts. One of it is rapid transition of the projects already being worked in phase one. So we can cover a myriad of technologies. We have scanning using the Creaform HandyScan 700. We use fused deposition modeling of many different machines, powder bed fusion, direct metal laser sintering, laser engineered systems, lens processes. We have a lot of technologies underneath this program, and it's really enabled us to meet the specific needs of the partners that we work with. We've had the C-130s here at YARS, which has been an excellent platform for us to learn about their needs. But we've also had F-16 opportunities at Hill Air Force Base doing repair operations both on their tails and other parts. We've had components at Robins Air Force Base for the C-5 to demonstrate rapid tooling for them. But many parts, many systems, and it's just fun to watch. You know, these system program offices where this is absolutely new. They don't know how to qualify and certify these parts. So you've got the research community trying to help with lots of data and developing the procedures, but you've also got the operational level doing the training, teaming with them, so that hopefully as an entire community we can move the whole technology and get the sustainment world operational as far as additive manufacturing capabilities.
If we're able to sustain our systems more cheaply with high quality parts, that saves us funding that can go to other priorities or to increase our capabilities in other areas in the Department of Defense. And so these effects are broad-based but very real.
There is a lot of excitement about it. It's fearful excitement because we really don't know what that means. And I'm hoping that in the next year that if we can start to qualify a part on the 130 and we can do that once and print it and say, here, put this in, that will actually start to change hearts and minds.
It's enabling our fighters to stay on mission. If they've got the equipment that they need to protect us and to protect themselves while they're doing it, that's really hard to quantify, but it means soldiers that come home and greater ability to impact the world outside of our borders as well.